Okay, go.
Hi, Claire.
Hi, Claire.
Good luck.
Oh, that's to stop it.
Wait for it. There you are.
Wait, guys, technically half will be.
Is that everybody?
Hi, Catherine.
Okay. Cool. Here we go. So today we're talking about applying properties of chords. So we're looking at chords today. We've got some theorems. All right. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Ooh. So let's draw a picture of what that would look like. So I'm going to draw just a little circle here. Actually, I'll do it up here. And I'm going to draw two chords that appear to be congruent. So it says, in the same circle or in congruent circles, two minor arcs are congruent if and only their corresponding chords are congruent. So if I label this A, B, C, and D, and I'm given that. Let's say I'm given that. That tells me that this arc, I'm going to use a different color than that. This arc right here and this arc right here are congruent. Those are minor arcs, okay? So I can say arc AB is congruent to arc CD. That's what that means. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. Ooh. Let's draw another picture. Small circle. That's a really lopsided circle, but that's okay. So I'm going to say one chord here. I'm going to draw a chord that goes all the way across. That's SQ. But if I'm told this, it says if one chord is a perpendicular bisector of another chord, that would look like that. Then the first chord is a diameter. I'm going to label this T and R. If I'm given that picture, I can say which chord is the diameter? SQ. So SQ is the diameter. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So we can still use this picture here. If the diameter of a circle is perpendicular to a chord, then we can say it bisects the chord and its arc. So it bisects this arc right here. That makes this angle congruent to that angle. Does that make sense? I mean, it would be if it's perpendicular anyway. All right, 10.6 is a little different. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So we're going to draw another circle here. We're going to have a center. It says in a circle or in congruent circles, two chords are congruent. So I'm going to draw a chord like this and maybe like this. They are congruent if and only if they are equidistant from the center. Now remember how we measure distance the shortest way. It has to be perpendicular to the line. So if I'm told this, if I'm shown that, that tells me that those two chords are what? Congruent. It tells me those two chords are congruent. They're equidistant from the center. Cool? That's what we're working with today. Alrighty. Use the diagram of circle D. If measure of arc AB, right here, is 110 degrees, find the measure of arc BC. Okay. Using this stuff up here, what do we see? What else did they give us in this picture?
Distance.
They gave us 9 and 9, right? Okay, so I know that these chords are congruent what else does that tell me about the circle? Yeah, if these are congruent, then these arcs are congruent as well. I'll just mark it like that. Right? So what they did tell me was they told me that AB is 110 degrees. So how could I find out what this distance is? What? Say it loud. It's guess. This is arc. Oh wait, the measure of AB. I'm sorry, right here. You're right. This is 110, so this is what? 110. All right, if the measure of AC is 150, what's the measure of AB? So this is 150. So what would we do?
360 minus 150 divided by.
Exactly. Because of congruent chords. AB, this is just an addition when you're going back and looking if you need to. This would be 105 degrees. Because of congruent chords, AB is congruent to BC. Arc AB is congruent to arc BC. Cool? All right, turn it over. Use the diagram of circle C to find the length of BF. All right, so the diagram of circle C to find the length of BF. Let's go back and look. What do you think?
Since it bisects because of the 10.4 theorem, we can say that it's
Great. So that's what I would say. Okay. Theorem 10.5 actually. It says the diameter, if the diameter is perpendicular to the chord, it bisects the chord. So we can say BF is equal to 10. All right, find the measure of the indicated arc in the diagram. So let's look here. What do we see right here? What's this? Bisector. So that tells me what? That tells me this is congruent to this, correct? And if those two are congruent, then what does it tell me about their arcs? The arcs are also congruent. So I can solve for x. So just do that. 9x equals 80 minus x. Add x to both sides. And x equals 8. So what would CD be then? 9 times 8, which is 72 degrees. What would arc DE be? The same, right? It's the same. You could do 80 minus 8 if you needed to. But you probably don't have to. These are congruent. And then arc CE would be what? 144. You add the two together. Okay? How do you know not to go this way? What do you think?
Because it doesn't say B.
It doesn't have the B in it. Okay, a major arc, which is going to be bigger than 180, would have those 3 letters in there. But this is a minor arc because it's only got the 2 letters. So we go this way. Even though the D is here, it doesn't matter. It's a minor arc. We're just using the 2 letters. Make sense? Okay. In the diagram of circle P, PV is equal to PW. They show us that. QR is equal to 2x plus 6. And ST is equal to 3x minus 1. Find QR. Well, what does this diagram tell us about these 2 chords? They're congruent because they're equidistant from the center. So theorem 10.6. The chords are congruent because they're equidistant from the center. Therefore, the arcs are congruent. Well, we don't even need to know that. We just need to know that the chords are congruent. So we can set them equal to each other. When you solve that, you get x equals 7. But we're not done, right?
You have to plug it in.
Yes, we need to know what QR is. 2 times 7 plus 6. And that equals what? 20. Boom. Cool?